Hello everyone. Today we're going to discuss how to solve radical equations. Let's take a look at the do now. We have two problems that look alike. What is the difference between the first and second problem? If you notice, in the second equation, the square root sign includes a variable, whereas in the first equation, the square root is under a number and there's no variable underneath. This is what the last lesson dealt with, how to solve equations of this type. Today, we're going to talk about how to solve an equation of this type. By definition, okay, let's write this down. Definition. A radical equation in one variable is an equation in which the variable is in the radicand. Last time we solved equations containing radicals, but a radical equation is a special case, and that's number 2. So let's just review. To solve number 1, we would isolate x here. So we would subtract the square root of 4, which actually is 2. So we would take that. We get 3x equals 8 minus 2. 3x is equal to 6. And dividing both sides by 3, we get x equals a half. In the second equation, to clear the radical, though, because we do want to isolate the 3x, which is underneath the radical, what we do is we square each side. So let's do that. And when we do this, we get 3x plus 4 is equal to 64. 3x is equal to 60, and x is 20. And that would be the solution. It would appear, let's just double check it. So when we substitute the 20 in here for x and add 4, we get the square root of 60 plus 4, which is the square root of 64, and that's just 8. So it checks, and that's the solution. Let's try a few more. Let's look at this one, 3. And that is the square root of 5x minus 1 plus 3 is equal to 0. Okay, now to solve this radical equation, before we square each side, it would be a good idea to isolate the part with the radical. So we rewrite that as the square root of 5x minus 1 equals negative 3. And we proceed it the same way. We can square both sides. And we get 5x minus 1 equals 9. Add 1, we get 5x equals 10. And it looks like x equals 2 would be the answer. But let's check it. So when we substitute this back into the original, we get 5 times 2 minus 1 plus 3. We get the square root of 9 plus 3. That's 3 plus 3. And remember, the square root of 9 is just 3. And that's 6. This is not equal to 0. So this does not check. And the solution set here is empty. The empty set. Now let's see what happened. Why didn't this check? Well, when we check in algebra, we're really checking to see if the steps are reversible. And that's starting with the answer. Can we go back to the original? Well, if x equals 2, 5x equals 10, that's correct. And if 5x equals 10, then 5x minus 1 equals 9, that's correct. And notice that we got this equation by squaring each side. But here, this is the flaw. If a equals b, is it always true that then a squared must equal b squared? And the answer is no, because if b is negative, when we square it, we would get a true result. So because we squared a negative here, that's where we got this extraneous root. So the steps are not reversible from here to here. If a squared equals b squared, if a squared equals b squared, then a does not have to equal b. Whereas if a equals b, then a squared equals b squared. That part is true, but the converse is not true. So that's where it failed. So if a equals b, then a squared equals b squared. But if a squared equals b squared, here we notice that a does not have to equal b, and we've gotten our extraneous root. Okay, we're going to investigate this algebraically in a minute, but let's take a look at the next one. Or actually, the second one. Notice that in this problem here, we cannot have a square root of a number that's a negative number. So at this point, we could have realized that the solution set was empty. Okay, so let's move back. Okay, our next problem is the square root of 4 minus x minus 2 equals x. So let's first isolate the radical. We square both sides. I make a separate step out of that one. And we end up with 4 minus x equals, and when we FOIL this, remember this is x plus 2 times x plus 2, we should get x squared plus 4x plus 4. Bring everything over to one side. We subtract the 4, which makes that disappear. Oh, plus a 0. We add the x, and we get 0 equals x squared plus 5x. Then we factor this. We could factor out an x, and we get x plus 5. So the two possible solutions are x is 0 or x plus 5 equals 0. So x equals 0 or x equals negative 5. We should check it. So we'll check x equals 0, and we get the square root of 4 minus 0 minus 2. Is that equal to 0? Well, this is the square root of 4 minus 2. Is that equal to 0? 2 minus 2 does equal 0, and it checks. Let's check x equals negative 5. Okay. So we get 4 minus negative 5 minus 2. Is that equal to negative 5? Okay, so we get the square root of 9 minus 2. Is that equal to negative 5? 3 minus 2 does not equal negative 5, so we reject this solution, and the solution set is just 0. Okay, so let's summarize. To solve a radical equation, first we isolate the radical. Then we square both sides. We solve for the variable using algebra. And you might get a linear equation, you might get a quadratic equation. And the most important step, this is a very important step, check each solution by substituting back into the original radical equation. Okay, that's a very important step. Okay, going back to the first one, to this page. So that's basically it. So let's take a look at the graphical approach. What do the graphs say about this? Messed up. Oops. Okay, so let's see what this all means graphically. So going back to the first problem, the square root of 3x plus 4 equals 8, we'll graph y equals the square root of 3x plus 4 and y equals 8. And notice that these two curves intersect here, 28. Okay, a square root function, which is the square root of a linear function, will always have this appearance. Notice that it is always above the x-axis. All right, if we look at the second equation, the square root of 5x minus 1 plus 3 equals 0, y equals 0. This square root function and the x-axis, whose equation is y equals 0, does not intersect. When we squared both sides, we tricked the graph into thinking that it would include this bottom piece, which would give us that extraneous root around here. And then finally, y equals the square root of 4 minus x minus 2. Well, it's the parabola this way, moved down 2 units. Not the parabola, the square root function, excuse me. And y equals x. There's one intersection point here. And again, when we squared both sides, algebraically, we're taking into consideration this bottom branch, which would intersect the line around here, and that would be the extraneous root. Okay, so that's the graphical interpretation. Wait, hold on, I missed. Now I would like you to try these problems. Okay, number 4. Okay, and that is the square root of 6x plus 7 minus x equals 2. And 5, the square root of x squared minus 3x plus 3 equals x minus 1. Okay, copy those problems down, pause, and replay to check. Okay, so I solved these for you. Here we isolated the radical. Okay, I'll just go over these. Isolated the radicals, squared each side, ended up with the same binomial squared, factored the quadratic trinomial. First, we got it in standard form. The two possible roots are 3 or -1. We substitute back into the original radical equation, and we see that -1 is the only one that works. So the solution set for number 4 is -1. This one, again, this one was pretty straightforward. We squared each side. We ended up with a linear equation because the squares appear on each side, so they cancel. We get x equals 2, and when we substitute into the original radical, that checks as well. So all of the work is here if you'd like to double check it. All right, we're moving along to the next one. Yeah, this is our answer. Okay, now what would we do when we have something like these? Okay, so to solve this, we still isolate the radical. We square both sides. Okay, so we get here 2x plus 3 And let's look at this very carefully. So 4 minus the square root of x minus 2 times 4 minus the square root of x minus 2. Okay, well, if we look at that, the first terms give us 16. Okay, the outer term gives us negative 4 radical x minus 2, and the inner terms give negative 4 radical x minus 2. So far we have 16 minus 8 times the square root of x minus 2. The last terms are tricky because a negative square root of x minus 2 times a negative square root of x minus 2. We could think of this as a negative 1. So if we square this, negative 1 times the square root of x minus 2 squared, remember we bring the square over to each factor in the parentheses, so that's negative 1 squared times the square root of x minus 2 squared, and that gives us 1 times x minus 2. So we just add x minus 2. All right, so combining like terms, we get 2x plus 3 equals 14 minus 8 times the square root of x minus 2 plus x. And we isolate this radical, so we subtract the 14, and we're going to subtract the x. So we get x minus 11 equals negative 8 times the square root of x minus 2. Okay, we can isolate this radical more by dividing each side by negative 8, but I'm going to avoid the division, and we're going to square both sides here. Oh, actually, I should make a separate step and follow my own rules, so let's do that. So I'm going to rewrite this as x minus 11, rewrite it, square each side, and we get x minus 11 equals, and again we have to square each factor inside the parentheses. So we get negative 8 squared, which is 64, and the square root of x minus 2 squared is just x minus 2. And we solve the resulting equation. Oh, actually, I did not do this correctly. X minus 11 squared, I have to FOIL that out, is x minus 11 times x minus 11. So that's x squared minus 22x plus 121. And now we solve the resulting quadratic equation. So we distribute. 21 equals 64x minus 128. Bring these over to the other side to rewrite the problem in standard form. And we end up with, oh, okay, I lost it somewhere. X squared minus 86x equals 204 plus 249 equals 0. And this one's a little hard to factor, but two factors of positive 249 that add up to 86 would be 3 and 83. So we have x minus 3 times x minus 83 equals 0, x minus 3 equals 0, or x minus 83 equals 0, x is 3, or x equals 83. And now we check it, so let's do that here. We'll check 3 first. So we get the square root of 2 times 3 plus 3 plus the square root of 3 minus 2. Does that equal 4? Well, this gives me the square root of 9, I believe, plus the square root of 1, and that does equal 4. 3 plus 1 equals 4. So that checks. So this one checks. If we check 83, we get the square root of 2 times 83 plus 3 plus the square root of 83 minus 2. Does that equal 4? All right, well, let's see what we get in here. We get 106 163 plus 3. That's 169. The square root of 169 is 13. Plus, well, right away, we see that it won't check. But just to complete the check, we see that 13 plus 9 does not equal 4. So that one is rejected. We reject. So the solution set here, I'll put it over here, is equal to just 3. And I'll highlight it here. And we reject this one. Okay, so we see that we have radical equations where it might be necessary to square both sides twice. All right, so now I'd like you to try these yourself. This is our answer. Oops, wait, I think I got to the wrong page. Okay, number 7. The square root of 5x plus 6 plus the square root of 3x plus 4 equals 2. So pause the button, copy the problem, pause, and check your answer by replaying. Okay, so we solved it here. I isolated this radical, brought it over to the other side, this one here. And then we squared each side. Just be careful here. When we square a binomial, it's useful to know that a minus b squared is equal to a squared minus 2ab plus b squared. So here, the 2 squared a is 4. Twice the product of the 2 and negative root 3x plus 4 would be negative 4 square root of 3x plus 4. And then when we square the last term, we just get 3x plus 4. So be careful there. Or that's the key step. So we combine like terms in this step here. We divide each side by 2 to make it a little easier. And we end up with this equation. We square each side again. And again, we FOIL this out, and we bring the terms over to one side. We get this quadratic x squared minus 14x minus 15 equals 0, which is factored into x minus 15 times x plus 1. And the two possible answers are 15 or negative 1. Okay, now we have to check it. So I'm going to write the check up here. So first we'll check 15, and we get the square root of 5 times 15 plus 6 plus the square root of 3 times 15 plus 4. Does that equal 2? That doesn't look like it would equal 2, but let's just go through it anyway. This gives us the square root of 81, and this gives us the square root of 49, and that definitely does not equal 2. 9 plus 7 does not equal 2. So we reject 15. Let's check negative 1. Okay, so when we substitute negative 1 in there, we get 5 times negative 1 plus 6 plus the square root of 3 times negative 1 plus 4. Does that equal 2? Okay, this gives us the square root of 1, and this gives us the square root of 1, and yes, that does equal 2. So our answer here is just negative 1, and that's our solution set. Here we go. I just put this in red. Okay. All right, so that takes care of the lesson with radical equations. And I hope that this would answer any questions you might have. A nice problem to think about would be the following. And I'll challenge you with an extra credit. And that is, what would you do if we have a radical equation with a cubed root? So let's do the cubed root of 1 plus x plus the cubed root of 1 minus x equals the cubed root of 2. You can solve this just by going over a few numbers, I'm sure you'll be able to get the solution set, but I'd like you to prove the solution set. So try it by yourselves. It's a great exercise. Here's another one. Show that, using algebra, that the square root of x plus 1 plus the square root of x plus 4 equals the square root of x plus 2 plus the square root of x plus 3 has no solutions. And show that algebraically. Okay, that takes care of our lesson, and I wish you all a very safe and healthy week. Take care.